Hello friends, welcome to YouTube channel Electronics. In this video, we will learn how to use digital multimeter. A digital multimeter can test various electronic components like resistors, transistors and can measure voltage, current and frequency. We will also discuss various key functions of DMM in order to get best out of it. The phase of a multimeter can be divided into 4 parts. First one, display, where we can see measurements. Second one, buttons, for selecting various functions. Third one, dial or rotary switch, for selecting measurement values like ohms, current and voltage. And the last one, input jacks, where test leads can be inserted. We will briefly discuss these 4 parts one by one. First one, display. If the number of digits or counts a meter can display on its screen increases, then it improves precision of the meter. I have summarized it in this conversion table. Apart from this, there are various symbols may appear when we are taking measurements. We will discuss these symbols when taking measurements a little later in this video. The second part of the DMM is buttons. There are 5 basic function buttons available in a DMM. However, a variety of buttons may available in high-end multimeter model. Next one, dial of the DMM. It is a main rotary switch to select the type of measurement to be made, like voltage, resistance and etc. Every character or symbol represents a measurement. The manual range multimeter's dial may appear like this. Next part is input jacks. We will connect test probes to input jacks. Generally, there are 4 input jacks. First 2 jacks are red test lead input jacks for measuring current, amperes and milliamperes respectively. Third one is common jack, black test lead input for all measurements, and the fourth one is red test lead input jack for measuring voltage, resistance, diode, continuity and etc. Let's start with how to measure AC voltage with DMM. To do this, we must insert the test leads in these 2 input jacks. Black probe at common and red probe at voltage input terminal. But there is no difference between these 2 probes other than color. We must insert the test probes like this. Then identify this AC voltage symbol on the dial. Then turn the dial to AC voltage position. Multimeter will power up and we can see AC voltage symbol on the display. And most multimeters power up in auto range mode. This automatically selects a measurement range based on voltage present on the test probe. While holding the test probes, never let your fingers to touch the metal part of the test lead. It is highly advised to wear rubber shoes, gloves and PPE kit. One more caution is that never allow the metal parts of the test leads to contact one another. Now connect the test leads to the circuit, black lead first and red lead second. We can see AC voltage reading on the display. AC voltage does not have polarity, so the polarity of the probes doesn't matter here. This is how we check AC voltage in a circuit. There are some additional features in a DMM. Let's discuss them quickly. With the multimeter still connected to the circuit, press this yellow shift button. Meter display will show frequency of the AC voltage. Hertz symbol will appear on the display. This means the yellow colored character Hz on the dial can be selected by pressing yellow shift button. If we press this shift button again, the meter will again change it to AC voltage mode and displays AC voltage reading. With the meter still connected to the circuit, now press this hold button. Hold symbol will appear on the screen. Disconnect the test leads from the circuit. Meter still displays the captured reading. This means hold function captures and freezes the reading. Reading can be viewed after the measurement is complete. This function is very helpful when troubleshooting on a live circuit. If this type of wave symbol appears on the screen, then the meter is in auto hold mode. Now the meter freezes the measurement on the display and automatically updates reading with a new stable reading. To unfreeze the captured measurement, just press the hold button again. DMM will enter into normal mode and it's ready for next measurement. Next, range function. The advantage of an auto range multimeter is that we need not to select a range. The meter automatically selects the range with the best resolution. However, if you want to select the range, this range button allows us to do manually. If we press this button, meter switches to manual mode. Now user needs to select the best range for this measurement. Here the meter is in 0 to 6 volts manual range. If we measure 220 volts AC in this range, meter's display will show OL. Just press this range button again. Meter will enter into next range 0 to 60 volts. But this range is also smaller for the 220 volt AC measurement. So meter still displays OL. Push the range button again. Now the meter will enter into 0 to 600 volts range. So the multimeter will display the measurement value as 220.9 volts AC. If we push this range button again, then the meter will enter into next range of 0 to 1000 volts. But if we observe the reading here, the meter reads the measurement as 222 volts instead of 220 volts. Meter reads 220.9 volts in the 0 to 600 volts range and 222 volts in 0 to 1000 volts range. It is to be noted that the higher the range we select, the lower the accuracy in reading. Here in this table, I have summarized the available manual ranges and their resolutions. As we increase the range, accuracy in reading will decrease. If we want to restore the auto range function, just continuously press this button more than 2 seconds. Auto range restored here. Always pay attention to these characters in the display. If small m appears on the display, that means multimeter displaying millivolts. For a manual range multimeter, always remember to set the next highest range for our measurement. For example, if you want to measure 200 volts, then we must choose next highest range 600 volts. Next, min-max function. This button allows us to read lowest, highest and average values of our measurement. Just press this button once. Multimeter enters into manual range mode. Highlighted min-max and max character shows on the display. If we measure the 220 volts, here the meter reads maximum value of the measurement, that is 229 volts AC. Let's discuss what this function actually measures. As we know, alternating current varies with time and multimeter measures RMS value of these variations. If we observe these variations with an analyzer, we can see small variations in their peak values. Because of the variations in the peaks, the meter's RMS value measurement will also fluctuate. Suppose if the RMS value is fluctuating between these two values, we can consider this lower reading is minimum value and upper reading as maximum value. This 229 volts is maximum value of this measurement. Just press this min-max button again. Now meter enters into minimum value mode and displays the minimum value of the measurement. Here our minimum measurement is 209 volts and maximum measurement is 229 volts. If we calculate the average value, it must be 219 volts. Just press this min-max button again. Meter will enter into average value mode and displays the average measurement value of 219 volts AC. If we press continuously this button up to 2 seconds, then normal reading mode will be reactivated. This small round button is a lamp function of the screen. If we press this button, backlight of the screen gets on. Press it again. Backlight gets off. By using these function buttons, we can get best out from the multimeter. High-end multimeters comes with additional function buttons. This relative function is very important one. The relative mode basically stores existing reading and resets display to 0. Sets relative reference point to measure against the next reading. Let's discuss this real function with one good example. Just imagine power distribution in your home. From main supply board to various wall sockets throughout your home. First, measure voltage at main circuit breaker. Suppose it shows 220 volts. With the meter still connected to the mains, press this relative button. The relative symbol appears on the screen and immediately reading becomes 0. What happened here is this 220 volts reading becomes the new relative measurement point for the next readings. If you measure the voltage at any other wall socket in your home, if your meter shows 2 volts, then it means there is a change of plus or minus 2 volts with reference to your first measurement. Here in this socket, the actual voltage is 218 volts or 222 volts. Press this relative button again. Your meter exits from relative measurement and shows actual voltage present in the socket. Now let's discuss what is the distinction between standard and true RMS multimeter. All multimeters are capable of measuring RMS value of pure sinusoidal AC waveforms. The difference in measurement accuracy occurs when we are measuring non-sinusoidal AC waveforms like square waves, triangular waves, and etc. True RMS multimeter ensures that we will get the most accurate measurement no matter what the actual AC waveform looks like. Here in this table, I have summarized the difference between standard and true RMS multimeters while measuring different types of waveforms. The difference will be up to 40% low or 10% high in its calculations. Now next topic, how to measure DC voltage with digital multimeter. Just locate this DC voltage symbol on the dial and turn the dial to DC voltage position. DC voltage symbol will appear on the screen. Most multimeters power up in auto range mode. Confirm this auto range. Now connect the test probes. Black probe to the negative terminal, the red probe to the positive terminal. After connecting the probes to the battery, multimeter automatically shifts to new range level. This is 12 volts battery. So meter automatically shifted to 60 volts range and the voltage of the battery will be shown on the multimeter's display. Modern multimeters automatically detects polarity. If you connect the test leads in reverse order, it doesn't matter. Meter will show negative symbol. One of the most important point is that while measuring AC voltage, it is very common to see variations in the reading. But with DC voltages, even a small variation may indicate trouble. Please refer manufacturer's specifications. Here in this table, a full charge 12 volts auto battery voltage ratings and its state has specified in open circuit condition. A measurement of 11.9 volts indicates a dead battery. 12.6 volts measurement indicates fully charged battery. In between measurements indicates a charge less than 100%. Now we will discuss about some key functions which makes us to get best out of this measurement tool. First one, range function. If you push this button, meter switches to manual range. By selecting the lowest possible range, we can get the most accurate measurement. For example, if we measure a 12 volts battery with 60 volts range, then the meter reads 12.06 volts. If we change the range to 1000 volts, then the meter reads the battery voltage as 13 volts. This type of measurement errors can be eliminated by setting the meter to the lowest possible range. Auto ranging restored when pressed this button for 2 seconds. Hold function. If you press this hold button with the meter still connected to the circuit, then the meter captures and locks the measurement on the display. So we can view the measurement after disconnecting the meter from the circuit. Now next topic, how to measure DC millivolts with digital multimeter. Millivolts are very small voltage. 1 millivolt equals to 1,000th of a volt. Sensors like thermocouples produces small voltages in terms of DC millivolts in an electric circuit. To measure millivolts, identify DC millivolt symbol on the dial and turn the knob to that position. Meter turns on and DC millivolt symbol appears on the screen. We can measure up to 600 millivolts with this DMM. A thermocouple is a temperature sensor used to figure out how hot or cold something is. It consists of two dissimilar metal wires that are joined together to form a junction. When the temperature at this junction changes, a small measurable voltage will generate at the other ends of the wires. The amount of voltage produced will depend on the amount of temperature at the junction. We can measure this small voltage with the DC millivolts function in the multimeter. Just connect the test probes of the meter to the two ends of the thermocouple and ignite a candle or other heat source at the junction. A good thermocouple produces 25 to 30 millivolts. The multimeter shows this millivolts reading on its display. Next topic, how to measure resistance with DMM. Identify this ohm symbol on the dial and just turn the knob to that position. Meter switches on. Mega ohm symbol appears on the screen and default test range is auto range mode. Display shows OL reading. This is because now there is an open circuit between the test leads. Just short the test leads. Ideally, the meter will show 0 ohms reading, but practically meter may read 0.2 ohms to 0.5 ohms reading. This small resistance is because of the test leads resistance. We must consider this resistance value as 0. Otherwise, use this relative function to make the display value to 0. Before measuring resistance in a circuit, ensure that power is disconnected. And if the circuit includes capacitors, discharge them. If the component is in the circuit, the measurement could be affected because of the other parallel components in the circuit. So it is advised to remove one end of the resistor from the circuit to get best results. Now connect the test leads across the component being tested. We will get the reading on the display. Almost all resistors have color coding or marking printed on their surface to denote their value. We must compare the marked value with the reading on the meter's display in order to know whether the resistor is okay or not. If you press this range button, meter will enter into manual range mode. Now user can set desired range for the measurement. Here in this table, I have summarized the available ranges and their resolutions. To get accurate reading, we must select the lowest possible range for the measurement. By using function buttons like hold, relative and etc., we can get best measurements from the meter. Next topic, how to measure capacitance with DMM. Identify capacitor symbol on the dial and turn the dial to that position. meter enters into resistance mode first. To activate this yellow colored marking, we must press this shift button. Now the meter enters into capacitance mode and we can see nanofarads marking on the display. Before measuring capacitance on the circuit, ensure that power is disconnected to the circuit and discharge the capacitors by connecting a 20 kilo ohm 5 watt resistor across the capacitor 2 terminals. We need to connect the resistor at least 5 seconds across the capacitor's 2 terminals in order to completely discharge the capacitor. Do not short the capacitor's terminals using a screwdriver or with any other metal to discharge the capacitor, as it may damage the capacitor. Visually inspect the capacitor if any bulges or other signs of damages in the capacitor. Replace them with new ones. Do not try to measure capacitance when it is in the circuit, as it gives inaccurate reading due to other parallel components in the circuit. Hence, disconnect the capacitor from the circuit board. The best way is to desolder the capacitor from circuit. Sometimes we can observe a small residual capacitance between the open-ended test probes. For accurate measurement of capacitance value, the relative mode can be used to remove the capacitance of the test leads. Press the REL button. This removes the residual capacitance value of the test leads. In case of polarized capacitors, connect the black probe to the negative terminal. Usually there will be marking on the side of the capacitor. And connect the red probe to the positive terminal of the capacitor. Generally longer lead. Keep test leads connected for a few seconds to allow the multimeter to automatically select the proper range. Now check the measurement on the display. If the multimeter reading are closer to the actual value mentioned on the capacitor, then the capacitor can be considered as a good capacitor. In case of non-polarized capacitor, we can connect the probes in either way, as they do not have polarity. If the meter displays OL reading, then the capacitor is faulty. A faulty capacitor may have lower or higher capacitance value than the actual value mentioned on the capacitor. Some multimeters have dedicated ports like this for placing capacitor to measure its value. If your multimeter didn't have capacitance setting, you can use resistance mode to test the capacitor. This method might not be accurate and doesn't give the capacitance value, but we can differentiate between a good and bad capacitor. Set the multimeter in ohmic range. Connect the multimeter probes to the capacitor terminals, negative to negative and positive to positive. Current flows through the capacitor and capacitor starts charging. A series of resistance values appears on the meter's display and finally progress towards OL reading. Now reverse the test leads. The capacitor starts discharging, so the resistance value keeps on decreasing. After reaching some lower value, the capacitor starts charging again. Hence the resistance value increases and finally progresses towards infinity. This type of action shows that capacitor is in good condition. Suppose if only constant very high value appears on the display, that indicates the capacitor is open, means faulty. Likewise, if the reading stuck at a very low value, that indicates there may be a short in the capacitor. It's faulty. Let's see how to test a capacitor by using continuity test mode. Set the DMM in continuity test mode. Connect the meter's test leads to the capacitor's terminals. Positive terminal to the red probe and negative terminal to the black probe respectively. If the meter shows a proper continuity with beep sound and gradually increases and shows an OL reading, it means the capacitor in a good condition. If the multimeter shows continuity with beep sound continuously, without any increase, it means the capacitor is short. It's faulty. If the multimeter doesn't show continuity with beep sound and shows OL reading, it means capacitor is open. It's faulty. Now let's discuss how to check continuity with multimeter. Just identify this symbol on the dial. It represents continuity mode. A continuity test tells us whether two things are electrically connected or not. Continuity test mode can be used to test switches, fuses, electrical connections, and etc. For example, a good fuse must have continuity. Just turn the knob to continuity mode position. Multimeter switches on in lowest resistance range and continuity symbol appears on the screen. Here meter showing OL reading because no electrical connection between the test probes. Now touch the probes with each other. If the meter beeps or gives 0 reading, that means the meter is working fine. Now take a fuse or wire which you want to test and connect the probes to both ends of the component respectively. If the meter shows 0 and beeps, it means the path is complete and allows the flow of current. A broken or open component does not allow the flow of current. So the meter shows 1 or OL reading and does not beep. Likewise, a good electric wire must have continuity. A damaged electric wire doesn't show continuity. We can test lengthy cables continuity by joining the wires on one side and connecting test probes on another side. A good electric cable must have continuity. We can also test the PCB's electrical tracks or connections. Just connect the test probes to any 2 points of the circuit board. If the 2 points are electrically connected, then the meter shows 0 and emits beep sound. Now connect the test probes to any other 2 connections. If the 2 points are not electrically connected, then the meter shows OL and doesn't emit beep sound. Next topic, how to use diode test mode. Diode test mode is used to test various electronic components like diodes, transistors, and etc. Identify diode symbol on the dial. Turn the knob to that position. Multimeter enters into continuity mode first. To activate diode mode, press this shift button. Meter enters into diode test mode. We can see diode symbol on the display. A multimeter's diode test mode produces a small voltage between test leads. It displays the voltage drop when the test leads are connected across a component when forward biased. First we start with diode testing in this mode. Diodes have 2 terminals, anode and cathode. A line mark represents cathode terminal. Just connect the test leads to the diode. Red probe to anode and black probe to cathode. Then the diode becomes forward biased. A good forward biased diode displays a voltage drop of 0.5 volts to 0.8 volts with a single beep. Now reverse connect the test leads. Black probe to anode and red probe to cathode. Now the diode becomes reverse biased. Meter displays OL reading when a good diode is reverse biased. A good diode must satisfy forward and reverse biased conditions. If the multimeter displays OL reading in reverse bias and also in forward biased condition, then it is a open diode. It is defective. If the multimeter displays the same voltage drop or 0 reading in both reverse bias and forward bias directions, then it is a shorted diode. It is defective. A defective diode either shows OL reading or same reading in both directions. Now we will see how to test transistors by using diode test mode. Transistors are nothing but 2 back-to-back diodes connected in series. They have 3 terminals: emitter, base and collector. Transistors can be categorized into two types, NPN transistors and PNP transistors. We can identify their type by using multimeter. Transistors are available in various packages. The pin configuration of various packaged transistors are specified here. Just connect the red probe to base and black probe to emitter. If the base emitter PN junction is forward biased, then the DMM will display a voltage drop of 0.5 volts to 0.8 volts with a single beep. Keep the red probe connected to the base, lift the black probe from the emitter and connect it to the collector. This may make the base collector PN junction forward biased. Then the DMM will display a voltage drop with a single beep. If the voltage drop of 0.5 volts to 0.8 volts appears when we connect red probe to base and black probe to emitter and collector one by one, then it is a NPN transistor. Now reverse the test leads. Connect black probe to base and red probe to emitter. This makes the NPN transistor's base emitter PN junction reverse biased and the meter should display OL reading. Keep the black probe connected to the base, lift the red probe from emitter and connect it to the collector. This makes the NPN transistor's base collector PN junctions reverse biased and meter should display OL reading. So it is clear that a good NPN transistor's reverse biased conditions must show OL reading. Also check the reading between emitter to collector terminals. DMM must show OL reading. PNP transistors checking is quite similar to NPN transistor. The only difference is that there is a change in polarity. Just connect black probe to base and red probe to emitter. If this makes base emitter PN junction forward biased, then the DMM will display a voltage drop between 0.5 volts to 0.8 volts with a single beep. Keep the black probe connected to the base, lift the red probe from emitter and connect it to the collector. If this makes base collector PN junction forward biased, then the DMM will display a voltage drop with a single beep. If the voltage drop of 0.5 volts to 0.8 volts appears with a single beep when we connect black probe to base and red probe to emitter and collector one by one, then we can identify the transistor as PNP transistor. Now reverse the test leads. Connect red probe to base and black probe to emitter. This makes PNP transistors base emitter PN junction reverse biased and meter should display OL reading. Keep the red probe at base, lift the black probe from emitter and connect it to the collector. This also makes PNP transistors base collector PN junction reverse biased and meter should display OL reading. So from this it is clear that a good PNP transistor's reverse biased condition must show OL reading. Also check the reading between emitter to collector terminals. DMM must show OL reading. This is how we can identify and check PNP and NPN transistors by the polarity of the meter's test leads. Now let's learn how to test a FET. With diode test mode of a DMM. FETs are two types, N-channel FET and P-channel FET. They have three terminals, gate, source and drain. It have PN junctions like transistors. They are between gate to source and gate to drain. Apart from this, source and drain terminals are connected to one channel. So we must get low resistance between these two terminals. Hence, by using multimeter, we can identify FET's source and drain terminals. FET's two terminals which shows low resistance while connecting test probes in any direction are called source and drain terminals. Now we can identify whether a FET is N-channel or P-channel by checking diodes between gate to source and gate to drain. A N-channel FET can be identified and tested by connecting red probe to gate and black probe to drain. This makes gate and drain PN junction forward biased. So the DMM will display a voltage drop between 0.5 volts to 0.8 volts with a single beep. Now keep the red probe connected to the gate. Shift the black probe from drain to source. This makes gate and source PN junction forward biased. So the DMM will display a voltage drop between 0.5 volts to 0.8 volts with single beep. So it is clear that if the voltage drop of 0.5 volts to 0.8 volts appears when we connect red probe to gate and black probe to drain and source one by one, then it is a N-channel FET. Now reverse the test leads. Connect black probe to gate and red probe to drain. This makes N-channel FET's gate and drain PN junction reverse biased and meter should display OL reading. Keep the black probe connected to the gate. Lift the red probe from drain and connect it to source. This also makes N-channel FET's gate and source PN junction reverse biased and the meter must show OL reading. A N-channel FET's reverse biased conditions are shown here. This is how we test N-channel FET. P-channel FET checking is quite similar to N-channel FET. Only we must alter the polarity of test leads. Just connect black probe to gate and red probe to drain. This makes gate and drain PN junction forward biased. Then the DMM will display voltage drop of 0.5 volts to 0.8 volts with single beep. Keep the black probe connected to gate. Lift the red probe from drain and connect it to the source. If this makes gate and source PN junction forward biased, then the DMM will display voltage drop of 0.5 to 0.8 volts with a single beep. So it is clear that if the voltage drop of 0.5 volts to 0.8 volts appears when we connect black probe to gate and red probe to drain and source terminals one by one, then it is a P-channel FET. Now reverse bias test. Connect red probe to gate and black probe to drain. This makes P-channel FET's gate and drain PN junction reverse biased and meter should display OL reading. Keep the red probe connected to the gate. Lift the black probe from drain and connect it to the source. This also makes P-channel FET's gate and source PN junction reverse biased and the meter must show OL reading. A P-channel FET's reverse biased conditions are shown here. This is how we test a P-channel FET. Now let's discuss how to test MOSFET with diode test mode of a DMM. Just like FETs, MOSFETs are two types, N-channel MOSFET and P-channel MOSFET. They have three terminals, gate, source and drain. Take a MOSFET and keep the MOSFET on a dry wooden table with the printed side on top and leads pointing towards you. Now take a meter probe and short the gate and drain pins. This will completely discharges the internal capacitance of the MOSFET. Now connect meter's black test probe to source and red test probe to drain. You should get an open indication on the meter's display. Now keeping the black probe touched to the source, lift the red probe from drain and just connect it to the gate terminal and bring it back to drain terminal. If the meter's display shows continuity, this confirms it is a N-channel MOSFET and the MOSFET is tested OK. For the P-channel MOSFET, the testing procedure will be same, but the polarities of the meter will change. Just short the gate and drain terminals to discharge the internal capacitance of the MOSFET. Now connect the meter's red test probe to source and black test probe to drain. You should get an open indication on the meter's display. Now keeping the red test probe touched to the source, lift the black test probe from drain and just connect it to the gate terminal and bring it back to drain terminal. If the meter's display shows continuity, This confirms it is a P-channel MOSFET and the MOSFET is tested OK. You can use the following test jigs to check any N or P-channel MOSFETs efficiently. Just press the push switch. If the LED glows only on pressing the switch, then it confirms MOSFET is OK. Any other results will indicate a defective MOSFET. Now we quickly shift into next topic, how to measure current with DMM. Just identify these symbols on the dial, MA and A. MA represents milliamperes AC or DC current for low current measurement. A represents amperes AC or DC current for high current measurement. Note that we must use these two ports for low and high current measurements along with common port. We must not use V port for current measurement. We use 400 mA socket for low current measurements up to 400 milliamperes and 10A socket for high current measurements up to 10 amperes. Insert the black test probe in common socket. We will not use this port for current measurement. We must connect red test probe in 10 ampere socket or 400 mA socket. I advise you to connect 10 ampere socket first. Now turn the dial to MA or amps position. Here also I advise you to turn to amps position first. Meter turns on and AC ampere symbol appears on the screen. The maximum current rating a meter can handle is 10 amperes or 20 amperes. It is always written near the amp socket. Don't try to exceed that range because overcurrent will damage the fuses inside the meter. That makes your meter useless for current measurements. Hence, I advise you to use high current socket first and don't exceed the limit of that port. Just push shift button. Meter shifts into DC current measurement mode from AC current. First, we must check the correctness of the fuses inside DMM. To do this, turn the dial to any position other than the amps and milliamp symbol. DMM should display the words lead and must emit a beeping sound. If this thing happens, then we can confirm that fuses inside the DMM are okay. Otherwise, fuses are blown out. We cannot take measurement without replacing fuses. Now look at this simple circuit. A lamp is connected to the battery through a switch and a resistor. If you want to measure current flowing through this circuit, unlike voltage measurement, we have to connect multimeter in series for current measurement. To connect multimeter in series, we have to create a break from one end of the circuit. So first switch off this circuit and create a break in this circuit. Connect red test probe to the break point which is clear to the battery's positive and black test probe to the other break point. If you observe over here, now the DMM is in series with this circuit. Switch on this circuit. Here meter display shows current measurement of this circuit. It is 0.2 amperes or 200 milliamperes of direct current. So 200 milliamperes reading is less than this 400 milliamperes level. So we will use milliamperes port and turn the dial to milliamperes position for accurate measurement of current flow. To change the settings of the meter, first we must switch off this circuit. Turn the dial to milliamperes position and change red test probe to 400 milliamperes port. First change the dial's position to milliamperes. On the display we can see milliamperes AC symbol, but here we are measuring DC milliamperes. To change into DC milliamps, just push shift button. Meter change it to DC milliamperes measurement mode. We can see the symbol on display. Next step, change the red probe to 400 milliamperes port. Here it is. Now switch on on this circuit. Lamp lights up and the meter is measuring 214 milliamps DC current flow in this circuit. If we reverse the test leads connections on breakpoints of the circuit, the meter's display shows same measurement but with a minus symbol. The same procedure we must follow to measure AC current in AC powered circuit. Remember, we must put meter on AC amperes mode. That's all about how to use digital multimeter. If you have learned from this video, please do mention them in the comment section below. Thanks for watching. If you like this video, please click the like button. Help others to learn by sharing this video. Please subscribe and turn on notifications for more such videos. Have a nice day.